Hello ladies and gentlemen, this is Big Fish, continuing my first video series for RaiseYourEdge.com on the basics of poker math. We will start with a short recap of what we learned in the first video, and then we will go ahead and unfold the solution for the given homework. Once we are done with that, we will dive into the fundamental tool set for any serious poker player, the expected value. We will learn about what it is and how we calculate it. Finally, we will, again, conclude that part with a small homework. So let's do a very short recap of part 1 of this video series. First of all, we learned about probabilities, being the fraction of favorable events taken from a pool of total events. They are calculated by dividing the good ones by the total outcomes and are expressed as percentages. Second, we differentiated between dependent and independent events. The total likelihood of dependent events is calculated by multiplying the probabilities of the single outcomes. Thirdly, we talked about how to get to the opposite, namely the likelihood that an event will not happen. And we learned that we easily take the remainder of 100%. As easy, and maybe even senseless that sounds, it will get severely important, so keep that in mind. Last but not least, don't ever more fall for the trap to incorrectly combine probabilities that don't belong together. You remember the example where I asked you for the likelihood to hit at least 1/6. That said, let's talk about the solution for our little homework. We set up a scenario where we were playing roulette. We bet on 17 and rules say that we win if we hit 17, lose if anything but 17 or 0 hits, and get a second chance to hit the 17 if 0 falls in the first attempt. If we succeed in the second attempt to hit 17, we stay break even, otherwise we lose as well. Fair enough. Now the first question was, what is the likelihood for us to lose our bet immediately? Namely losing in the first attempt, and second question was, what is the likelihood we lose our bet at all? Now the first question likely was fairly easy to solve. We got 37 possible events, namely the 0 and then all the numbers from 1 to 36. Only one of these, namely the 17, forms our quote-unquote favorable event. That said, the likelihood to win in the first attempt is 1 divided by 37, which is 2.7%. No big deal, I guess. Probably a bit more tricky was the second question. Again, let's dissect the possible scenarios step by step. On the top layer, we have to differentiate two different scenarios. Scenario A is that we lose immediately, which happens if we hit any number besides 0 or 17. The second possible losing scenario is that we hit 0 in the first attempt and then don't hit the 17 in the second run. As soon as we have that structured, we can assign the probabilities. Scenario A happens in 35 out of 37 cases, as there are 35 numbers that are neither 0 nor 17. That means in 35 of 37 cases we lose immediately. Everybody agree? Scenario B is a dependent event now. It can only happen once we hit the 0 in the first run. This again happens in 1 out of 37 times. 1 0 out of 37 numbers. Once that happened, we lose in 36 out of 37 times, as the 0 does not help us anymore. As you remember, dependent events got to be multiplied, which means the total probability for a 0 hitting in the first run and no 17 hitting in the second run is 1 divided by 37 times 36 divided by 37. Still there? Okay, now as we have all the single terms of our formula, we can build the whole. We have two different outcomes for the same scenario, which means we have to add them to get the total probability. So we take, in brackets, 35 divided by 37, which is the probability for losing immediately, and add the probability of hitting 0 and losing the second attempt, which is, again in brackets, 1 divided by 37 times 36 divided by 37. After solving that, we get a result of 97.22% total. That is the likelihood for us leaving the table without money. By the way, what you see here, this dissection of all possible outcomes, this deconstruction of the complex scenario into small manageable pieces, is exactly what I do all the time. There's no magic, no autistic genius behind doing that math. It's just taking step by step and finally reconstruct the whole formula. Obviously you will gain routine, so you will be able to make that quicker and quicker, up to the point where it looks as if you do it in your head, magically knowing the number. But that's just what it looks like. At the end, it's exactly what we did here. So train that over and over again, and you will see how your mental muscle will grow. Okay, back to the game. What did we learn from that? Exactly. Keep playing poker. Okay, so let's talk about the holy grail of poker theory, the expected value, abbreviated with EV. The definition is quite easy. EV is the profit we expect in case our quote-unquote favorable event occurs, multiplied with the likelihood that this actually happens. Again, a small example. If we got 20% chance to win $100, our EV is calculated by 100 times 20%, which comes down to an expected value of $20. If that sounds too theoretical for you, let's try to wrap that into easy words understandable for everyone. Statistically, we will win in 20%, which is every fifth time. At least in theory, but that we will talk about later on. So let's imagine we divide our potential win of $100 into 5 equal pieces of $20 each. So now we have 5 chances to win $20 each. In 4 or 5 times we will lose and get nothing. And once we will win. That means at the end, when the desk lays down, we leave with $20. Our win from having won one of those 5 times. And exactly that is our expected value for the initial game, where we had 20% chances to win $100. Now if you ask yourself how this makes any sense, as we either win 100 or nothing, so that $20 thing sounds like an arbitrary number that we will never actually get. Remember that we are not playing one single hand in our poker career, we are playing hundreds of thousands. And if we combine all these scenarios, the average we will have won will more or less exactly mirror our expected value. Obviously that demands a very big sample size, and likely many of you can sadly report how big the sample has to get before we can halfway count on getting what we deserve. But again, that's another topic which might get subject of a future video. Now let's talk about constructing more complex scenarios than just one outcome, win or lose, and the potential profit sum. In poker situations, we are often confronted with scenarios like, if I shove here, I might get a fold in 30% and a call in 70%. And when he calls, I will win in 35%, and so on and so forth. Scenarios can get arbitrarily complex, you name it. But at the end, these are just layers. The single items are always the same easy tiny brickets we talked about in the past. Let's visualize that with this simplified little game tree you can see here. So we have a root element, which could be a bet from us, and we have 2 different outcomes. Villain can either call or he can fold. If he calls, we can either check and fold on the next street, or we can fire a second barrel. For the sake of simplicity, I omitted any other options here. Now imagine each of these bubbles has a certain probability of occurring. Villain will call X% and fold Y%. Now do you remember the first video where we talked about adding probabilities that are just different outcomes of the same event? Here you are. One event, namely Villain's decision, and 2 possible occurrences. So as long as he won't die while tanking, he will eventually do the one or the other, which means both events add up to 100%. Now what to do with the vertical lines inside our tree? Again, remember video 1. these are dependent events. We can only check fold or second barrel once villain had called. And what do we do with dependent, namely and connected events? Exactly, we multiply their probabilities. Perfectly. Now let's get our feet wet with an example. Admittedly, a very simple one to start with. We flip a coin for $1. Again, we look at all possible results, which is A, we hit heads, which happens in 50%, and our net profit is plus $1. B, we hit tails, which again happens 50%. See, again, we can add up that to 100% as both occurrences are related to the same event. And we lose $1. That said, we can construct our EV formula, which is the probability of A times the net profit in case of A, plus, again remember different outcomes, same event, probability of B times profit of B. That ends up in 0.5 times plus 1 in brackets, plus, again in brackets, 0.5 times minus 1, for a total of 0. Then, who had that seen coming? But seriously, what does that 0 EV mean in practice? It means that if you flip long enough, your win per flip on average will be pretty close to 0. Obviously, when you flip once, you might either have won $1 or lost 1, which is pretty far away from 0. But if you keep playing, the difference between your actual win-loss and 0 will likely get smaller and smaller until it almost disappeared. Understandable? Cool, so let's talk about a second, more poker-related example. We are facing a river scenario where villain bets full pot, $100 in the pot, and he bets 100. We estimate to have 38% equity against his betting range. Now, do we have a quote-unquote statistically correct call? EV will tell us. So again, we have two different possible outcomes once we call. A, we call and win. B, we call and lose. When we set up the EV formula, we take the profit in case we win, which is 2 times the pot, namely 200, and multiply it with our equity. And add the second outcome, namely us losing, which results in a lose of 100, and which will happen in 62%, which is the remainder of 100% minus the times we win. In the result, we end up with a positive EV of $14. So let's crush these juicy games. So here's a short add-on for those of you who already might have some experience with EV calculations and wonder why my calculation looks more complicated than what you did before. All others can consume that, but there's no real need to fully ingrain what I explain here. I am talking about a different way of constructing the EV formula. Like what we did before was setting up the different outcomes and replace each by the product of probability and net profit, as you can see here. In case of our previous example, where villain bet pot, it would have been equity times bet plus pot added by 1 minus equity times minus bet. Fair enough, that was the way we did it previously. Now we can arithmetically, that will break my German tongue, transform that formula step by step. I will pass on explaining all the steps and instead just click them along to show you where I want to get. So here you are. What you can see here is exactly the same formula as we started with, eventually showing exactly the same result. It's just a different presentation, which we can prove by solving it. So you see, finally it's a matter of taste. But, and this is a big but, if you are fairly new or inexperienced with this EV topic stuff, I'd strongly suggest to stick with the previously shown way of constructing the EV formula, at least as long as you get sufficient routine with that stuff. Because the second form might look easier, less complex, but it's way less intuitive. And you're inherently at a higher risk to make mistakes in your calculations, which you won't be able to identify as easily as with the first one. That said, I can take down my finger again and conclude that video with your next homework. So this time we are actually playing poker. Hooray! Our scenario now is a semi-bluff on the flop with a nut flush draw. The pot is $100, villain bets 3/4 pot for 75 and we shove for 450. Now we estimate villain to fold in 55%. Once he calls, we estimate to have 20% equity against his calling range. So the question, big surprise again, is what is our EV? And again, I'd like to add two strong suggestions. One is, before you even start to do any calculations, try to guess what will happen. Do you expect to have a positive EV or a negative? Dare to guess how much roundabout? Second, actually do the calculation with pen and paper. No calculator, no Excel, and holy mother of God, no EV calculator. Don't betray yourself. This is just wasted time. You gain essentially nothing from cheating. Try to do it the quote-unquote hard way, and even more, do it over and over again. Actually, let me add a personal note again. Can you imagine why I am sitting here and producing videos about poker math? Actually not because I'm a math guru, not at all. It's simply because I trained myself hundreds of thousands of hours to do exactly what I show you here. Maybe not that much, but close to it. I have calculated literally thousands of different scenarios, and believe me, the first few dozens I have done with pen and paper. Actually, I did that until I got a natural feeling for it. And then I turned up the heat step by step. As often, there's no easy way, and this video is no exception. Get your own coach, train yourself, and eventually harvest the fruit of your hard work. An invaluable feeling. So again, thank you very much for listening and being patient enough to stay with me to the end. Good luck at the table, your big fish.